Hello friends, I am Sawan Pepper and today we are going to discuss about transportation problems. That is one of the chapter of operations research. So transportation problems, as we know, it involves the transportation of goods or any equipments or materials from one place to another place. So here we are going to discuss about that kind of typical problem. As you can see, here I have one diagram which indicating three plant A, B, C. These plant are manufacturing certain kinds of goods which are need to be supplied to the market. So in market, this plant having a distribution channel or any warehouse are available. So firm has to decide how these goods need to be transported from these three different plant which are located at different locations. Okay, so from these plants, how to supply the goods in optimal way which can occur a minimum transportation cost. So we are going to discuss about the transportation algorithm and how we can solve this kind of problems. So let's start with example 1 and see how this example can be solved. So in transportation problems, we have two steps to solve this problem. In first step, we will find initial solution, and in second step, we are going to optimize it. So for finding initial solutions, we have three methods. First is NWC or NCM, that is known as northwest corner method. Another one LCM, least cost method, and third one is Vogel's approximation method, VAM method. So after finding initial solution using any one of this technique, we can go for optimal solution, and that can be obtained by either modified distribution or stepping stone method. So in this video lecture, we are going to discuss about only initial solution by using a single example. We are going to see all these three methods very quickly. So let's start. So here we have example which we are going to solve by using a northwest corner method. So as you can see in this example, typical ABC three plants are given to you from where goods need to be supplied to PQRS market. Okay. So from this plant A, B, C, we have available supply. As you can see, from plant A, available supply is 500, B 300, and C having a 200. And demand particular we have for market P 180, Q 150, R 350, and S 320. Now before we start to solve this example, first we have to check the total of supply and demand available. You have to check this supply total which need to be matched with this demand total. If it is not, then it is an unbalanced problem, and in that case we have to add dummy row or column whatever required to balance this problem, and then we start. So here the total are same. As you can observe, both the total are 1000. So now we are going to solve this example by using a northwest corner method. As the name suggests, we have to start allocation from north west corner. So from this table, as you can see all this value are a transportation cost. Okay, say to transport a one unit from plant A to P, we require 12 rupees per unit. So these are indicating a transportation cost per unit. So as per the name northwest corner, this is our northeast west. As per the map, this corner is northwest, so we'll start allocation here. So whatever demand we have 180 and supply 500, so out of this two minimum value is 180, so we'll allot 180 here, so this will be satisfied. So we are going to allot here 180. So this demand is satisfied, and we have to remove 180 quantity from this supply. So we have to write down the remaining quantity, or you can remember it simply. So what is the remaining quantity? That is 320. Now after removing this column, we have next available corner is this one, northwest corner is this one. So we'll allocate transportation quantity here. Demand 150, available 320, so we can supply 150 here, and this demand has been satisfied, so we can strike out. Now next available northwest corner is this one. So now out of this 320 we again have consumed 150, so we have left with 170 units are left, and whatever the demand is 350, so we can only supply 170 here. Available quantity is 170, so this supply is satisfied, so we can strike out this row. Now from remaining value, the northwest corner is this one. Now out of 350, 170 is consumed, so what is the remaining quantity here? That is 180. You can simply remember it if you don't want to write it. Okay, now what we can allot here? 180 demand, 300 supply, obviously 180 we can supply here. So here this demand is satisfied, so you can strike out this. Next available corner is this one. So now remaining quantity here from supply, you have to deduct this 180, so remaining quantity is 120 here, and demand is 320, so you can allot here 120. So again this is satisfied, you can strike out. Remaining only corner this one, we having a 200 supply, and here out after 320 we have consumed 120, so left quantity is 200, so you can allot here 200. Okay, now you can do total cost finding like this. Total cost, as you can see here, 12 multiply 180 quantity plus 10 rupees multiply 150 quantity. Likewise you can total out the allocation here, and you will find the total transportation cost. That's it. So this is our northwest corner method, and this is the way of allocation. Now we'll see the next method, least cost method, LCM. So in this LCM method, as the name suggests, we start allocation from the minimum cost available here. So in this table, which one is the minimum value? This 6. So we'll start allocation from here. What is allocation you can make here? 180 is demand and 200 is supply. So we can give 180 here. So we have allocated 180 here, and this is satisfied, so we can strike out this column. Now from remaining value, which is the minimum value? This one. So whatever the quantity we can assign here, out of 200 we have already consumed 180, so left quantity is only 20, hence this row is also satisfied. Now from remaining value, which one is the minimum? 8, so we can allocate here. The demand is 350, supply is 300, we can only satisfy 300 demand, and you can strike out this row. Now from the remaining value, minimum value is this one, so you can allocate 150 from the supply. So again this column is satisfied, and remaining quantity is 500 minus 150, that is 350. Now minimum value is 12, so we can allocate here. Demand is 350 and supply is, so here we have 350 demand, so remaining demand is 50 only. So you can allocate 50 here, and this is satisfied. Now remaining value is only this one. So what we can allocate here, we have 300 quantity remaining, 50 is consumed, and here out of 320 20 is consumed, so we can allocate here 300. Okay, so likewise you can again calculate the total cost as per the allocation made. Here 10 multiply 150 plus 12 multiply 50 plus 13 multiply 300 plus 8 multiply 300. Likewise you can get the total cost. Okay. Now we'll move for the next problem. So now we will see how to solve this example by using a Vogel's approximation method, VAM method. It is also known as a penalty method. So here in this VAM method, we are going to take a difference in row wise as well as column wise. So in first row, we are going to take the difference of two minimum value. What is the two minimum value here? 6 and 7. So difference is 1. For this column, the minimum two value 10 and 11. So difference is 1 again. Minimum two value here 8, 11. Difference is 3. Here it is 7 and 13. So difference is 6. Now similarly we are going to take two minimum value difference row wise also. So in this row minimum two value are 10 and 12. So difference is 2. Sorry for the handwriting. Now the here two minimum value 7 and 8, difference 1. Here 6 and 7, difference is 1. Now out of all these differences we have calculated, so maximum value we have find here is 6. So we are going to allocate in this column which having a minimum value. Minimum value is 7, so we'll allocate it over here. Available demand is 320, supply is 200, so we can supply 200 here, and we can strike out this row. Clear? So what we are doing basically here, we are taking the difference of two minimum value, so that this will going to assign a route in such a way that, and this are indicating a penalty of not using a optimal route. So in previous method NWC we are going to allocate as per the corner available, northwest corner simply. In second method LCM we are allocating as per the minimum cost available, and here we are not allocating directly to the minimum cost, but we are taking the penalty of two minimum value difference, and this is a big having, which one having a big penalty we are going to allocate in that route. Okay, so that is the exercise here. Now we are going to take a second iteration. This row is deleted. Now we have to check from remaining two row. Difference is 12 minus 7, that is 5. Here the difference is 1, 8, 12, 4, 13, 14, 1. Similarly we are going to check difference in row wise. So row will be the same as we haven't changed anything, and this one is gun. Now in this second iteration the maximum value we have, out of all this value 5 is the maximum, So we are going to allocate in this column which having a minimum value. 7 is minimum value. Allocation value can be made 180, and this is satisfied. Now we are going to take third iteration. This is tracked out. Difference is 10 11 1, 12 8 4, 13 14 1. Similarly for the row wise, minimum to value 10 12, so difference is 2. 8 11, difference is 3, and this is gone. So out of all this, maximum value is 4. So we are going to allocate in this column having a minimum value. What is the allocation we can made here? That is 350 demand is here, and out of 300 we have consumed 180, so we can allocate here 120. You can understand this is 120. So this is tracked out, satisfied, and out of 350 120 is consumed, so remember it. Now we are going to allocate in this 3 value. We do not require further iteration as we have left with only this single value without allocation, and this demand need to be satisfied. So simply we put 150 here, and this is satisfied, strike out. 500 supply we have consumed 150, so remaining supply is 350. Am I clear? So out of this 350 supply, what we can supply here, that is remaining demand 350 minus 120, so we have left with 230. So you can supply 230 units here, and this is satisfied. Okay, now here remaining supply is 500 minus 350, 150 minus 230, so we have left with how many quantity? That is 120. Okay, and this will going to be add here, and total will be the same. So here we have got 500, and here this total is also become 320. So both the supply and demands are satisfied, and example is over. So this allocation has been made, and you can find out the total cost as indicated in the bottom. So 10 multiply 150, 12 multiply 230, likewise, and we have obtained this cost. So by using all these three methods, you can observe the minimum cost obtained is in this case VAM method. So VAM method is the most optimum method out of all these three initial solution methods, though it involves certain more calculations compared to other solution initial solution methods, but this one will give you optimal solution for the initial solution. Clear? Okay, up to this we are ending this session. uh, this session was only regarding initial solution method for transportation.